Hello. Recently, a puzzle contest I ran called Hexagony that I constructed alongside Eric Fox recently concluded. The gimmick was that the rules were all written so that the puzzles would work regardless of the grid shape, and each puzzle type has a square puzzle and a hexagonal puzzle. Today I'm going to start doing a walkthrough series for these puzzles, and I'm going to start with the Spiral Galaxies. This was the example puzzle. And to solve Spiral Galaxies, you just have to divide the grid into regions of edge-connected cells. Each region has one circle at its rotational center of symmetry. Alright, so that's pretty straightforward. So that means anytime that there's two circles sharing a cell, there's a line between them. And it also means that anytime it's on the border, you can rotate around and put the opposite border. And that gets you to here pretty quickly. The next really critical step to look for in a Spiral Galaxies is to try to find cells that can only be reached by one dot. In this case, my eye is drawn to this lower section, and in particular this cell in row 6, column 3. If you look closely, only one option exists for this cell. If it tries to use this black dot, it comes up here and it won't work. This one goes off the grid, this one goes off the grid, and that leaves here. So we're going to kind of draw this dotted connecting line. We're going to do it as free, actually. And so we essentially know this will be connected. But that now gives this border, and we can do the same kind of logic with this dot, with this square, and it goes to this dot. And now we can also get this line. This cell now must be used. This is now an edge, and we can kind of just step through the rest of this puzzle pretty quickly, as it just kind of resolves the rest of itself, all by looking at cells that can only be reached by one point. That's usually enough for a Spiral Galaxies puzzle, but it won't always be, and sometimes there are some more advanced deductions where things will where if a cell is taken by a dot, then it cuts off another cell from being able to reach by anything, or chains through, and we'll see a little bit of that in the next puzzle. So here we are at the next puzzle. This was a 35-point puzzle on the test, which, if you were trying to be on a finishing pace, 600 points in 120 minutes, this puzzle would take you about 7 minutes to complete. That doesn't mean I expect this to take 7 minutes to complete. In fact, I'd expect a lot of skilled solvers to be able to do it faster, but that's just the kind of pace that it was relative to test solving, and this is a type where an intuitive solve can be very different than a logical, rigorous solve. But anyway, we're going to be doing a rigorous solve here. We're going to start with all of the same forced edges that exist, just like the last puzzle. And what that's going to do is give us our first region. Now, there are no longer any really large areas that cannot be used by anything, or that aren't not currently dotted. So that makes this puzzle a little bit harder to reason about. This cell, however, still draws my eye, as if it's not going to use this dot, well, it can't use this one, so it would have to come out here. And then if it tries to use this dot, well, it's colliding. And if it tries to use this dot, it's also colliding. And then it could try to use here, and then anywhere else, it doesn't really have a room to go. So we can then do this. And I'm again going to use the dotted normal line here, just to show that this is, oh, actually dotted is as good as thin for this, I think. Yeah. Okay. So what other cells are like that? Well, here's one that's kind of limiting. It can go to down here, or it can go to over here. Those are really the only two options. But note that if it's going to come to this lower dot, then it's going to take this path. And note that if it goes here, well, it can't come through down here. It can't take this cell, so it would take this kind of path. In both of those cases, we get this. So that's what I mean. That's kind of a both paths lead to the same thing. You could also get to that by looking at this cell in particular and seeing that it doesn't have anywhere else it can go. You can also look at this cell on the other side, kind of the symmetrical placement. And we can see that it can't go to here, 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 so it kind of just has to go down. Now, that cuts off this cell from being potentially used by anything else. Therefore, it's used by this central dot. And where else is there progress? Well, as you can see, cells that are already next to dots that are restricted tend to be good places to look. And that means if we look right here, in row 8, where can this go? Well, here's the obvious placement, but you don't look at the obvious placements when you're looking for a contradiction, or a proof by contradiction, I should say. You're looking for the things that almost work, but don't quite work, and trying to disprove them. So if we look at this dot, well, that's immediately out. If we look at this one, the symmetrical point is up here, and that's out. All of this stuff's way too far out of the way. If we go around, well, then we can't take this. So it would require going through that border. Can we take the black dot? Nope, crashes into the white dot. This dot, however, seems like it might have a chance. As you can see, it would take up all of these cells, but, and this is the big but, there can be a problem with doing this. I don't actually know, or I should say I don't actually remember right now if there is a problem with doing this. But I think that if you were to take this cell and put it in this dot, now what happens to this blue square? Where can it go? What options does it have? And if you just look at the possible mirrorings, well, that's out. This one would come over here. This one doesn't work because now it crashes into our yellow region. This looks possible, except for the fact that, it still forces a collision. And so this is one of those second-level deductions that can be made to rule out this pesky case. And so we know this cell will do this and be taken by that dot. Okay. I tend to solve spiral galaxies mostly intuitively, so I'd kind of just be, if I was doing that, I would throw things down and then adjust where it doesn't quite fit right, but that doesn't exactly help with solving them rigorously. Obviously, because it's not a rigorous solve, and it doesn't really show how to do them, it just shows, hey, I can do it quickly. However, what I see is this cell down here. Cannot reach here. Note that the farthest this dot can reach is one cell short, and none of the other dots can really reach either. It makes this cell very clear. Gives us 2 more edges. Now, we don't know where this cell goes, but we know it has to come out, and that is actually very useful, because if we look for the places this pair of cells can go, well, given our progress over here, this dot is out. Nope. Nope. So it must go here. I think there's another second level deduction, where if we look, where we're going to go to surface for this one, this cell, it still has this option, that still exists. But what if we did that? What does that mean for this inside region? Well, something has to get here. And what can get here? Nothing at all. So that's actually more useful for this cell, where, if it comes around, then we've already broken the puzzle. And what that means is we now get this right side, and we can continue looking at this cell, only it's a little easier. The other option is to come up through this black dot, but, again, that's going to create some pretty forcing groups here. And this might be a little far to reasonably see, but, I mean, what options are there, really? You cannot ever hit this cell. As then this one has to come down. And this is a deep chain. And there may be a better way of approaching this, but that's just the kind of place I would look, and I would carry it out, and I see where it goes. But okay, can we get to that through a cleaner method? Can we show that this must go in here in a cleaner way? And we can look out around the end of that chain to try to determine that. I'm not really seeing a better way, however. There's something pretty simple, though. This cell, once we resolved this, only had one option. But yeah, we're just going to put this in as something that we know, where this cell cannot go to this black dot. Because if it does, we run into problems filling up the rest of the top. Okay. This area still seems pretty important to me. In fact, this cell in particular, this draws my attention now. Cannot go through here. Can't go through here. Can't grab this. Can't go to the black dot. This is an option, and this is the other option. So we kind of live in two worlds here, where it's going to do one of two things. But remember, we have this problem with the right side that needs to be resolved, and resolved carefully. Remember that we already saw the yellow having problems if it does, if it comes over here. And again, we put in these same forced deductions. And yes, I think that's the way to go about this. The cleaner way of going about this. So, one, we've proven this. But more importantly, even without this proof, look at this cell. And where can it go? It will take this cell, whether it goes down, or whether it goes here. Or even whether it escapes. But then it cannot take here. And that means anytime this cell, this particular cell, oh wait, no, this is not actually a proof. My bad, there was another case with this that I forgot about. So, my mistake, that was not a real deduction for what this does, but this is a real deduction, and that makes this a real deduction too. Where we don't know whether this line is going to go through this dot or this dot, but we know those two have to go together. That is a fact. This cell could still go over here and reach all the way. Here seems like a potentially promising lead. Again, using yellow to just highlight it. It cannot go down to any of these or over there, so this is the first real option. But is there a pesky case? Well, there is. It could potentially go to this black dot. But again, note what happens if it does. And what happens to this cell? What can take that cell now? Nothing, that's what. Therefore, that is connected. Okay, what next? Yeah, almost all of these cells still have two options. I still think this cell is, this one critical cell is the right place to look, though. Because, you know, what happens if it does come over here? Ah, yes, this does potentially cause some very real issues. In fact, it immediately does. So look it down here. It's now going to escape, come over here, and then nothing can take these spots down here. So, that would have been much simpler than some of the other things. This and this must go together in some way. Now remember what we know. This now creates an invisible barrier that prevents anything, this cell in particular, from escaping down. But it can't go to this dot, which we've already proven with this line. Therefore, it doesn't. And we get this kind of connection, which is going to create this large group. And I think that might finally get us going on the rest of the puzzle. I am obviously solving this again live. I've done it before, but it was a while ago. So we can now just take a couple quick deductions to see where it goes, how it goes. Extend this part down. This central block that we saw earlier is now resolved. What can reach here? Well, only the white dot in the middle. Is going to give us this line here, which I'm going to just I'll put it in for consistency's sake. What can reach here? Well, only the one. And now we do have a bit of a chain where we can where we're going to mark all of these as either on in blue. So if this is taken, this is taken. And so you can see how this kind of chains out. So if this black dot takes this cell, then it's this pair, this pair, this pair, and then this one would need to pair to over here. And all of that just chains around. Conversely, if it doesn't take the green, these are paired, and these are paired. We'll keep that in mind, as that should be very important for resolving the remainder of the puzzle. Let's also mark a red and yellow pair here, as we have another chain, essentially, that carries us over to here. But, as I put down this chain, do you notice something about this last cell? Do you notice something weird about it? Where are its other options now? They just don't exist. And that is the final big resolution necessary to solve the Spiral Galaxies puzzle. The rest is pretty simple cleanup, where we now do resolve this entire chain through the top, and this is the solution. I'm just going to clear the, just going to put in the rest of the lines, clear the formatting, or sorry, the surface. And one more thing before we go here. So this is the solution to the first puzzle of Hexagony, the regular Spiral Galaxies. And why would I put the 35-point puzzle first? One very simple reason. What better introduction than just telling you Hex? This is something that could have been used, could definitely have been used for a meta-level improvement. Especially if somebody wanted to take that chance. The original version of this puzzle had these two dots on the H and the X as black, but in order to kind of equalize the meta solving and the more rigorous solving approach, or even a more intuitive solving approach, I elected to replace them with white, figuring that the theme would still show through. And this is in fact why this puzzle is 9 by 15 and not square. So again, the really critical moment of this particular puzzle is this region up here, and just identifying that these two cells in the top right have to be linked, and then identifying this cell, after some progress in the bottom, that this cell must connect to here, and then the rest just kind of flows around. So definitely a tricky puzzle. This was the 4th or 5th highest point value puzzle on Hexagony, so if you struggled with it, no shame in that. If you had and if you were screaming at the screen for me to see things that were painfully obvious, good job. Alright, we'll move on to the next puzzle now. So the second puzzle on the contest was a hexagonal Spiral Galaxies. The rules are exactly the same, it's just everything's on a hexagonal grid. And that does complicate things a little bit. This was worth 20 points. I think this was a bit overvalued, but also dealing with the hexagons does make a lot of the reflecting of deductions harder, and it's just not as easy to see. So I think that 20 points was reasonable here, and that a lot of people probably got some good value out of it. This was obviously constructed by Eric Fox. So, what changes about the approach for the hexagonal Spiral Galaxies? Well, not really very much. Again, we can just take a look at this particular cell and see that it must start coming out. Can't go here. I'm just going to gloss over a lot of that. Can it go here? Nope, then it will collide immediately. Can it go here? No, because then it goes off the grid. And what that essentially gives us very early on is this entire bottom half. And some pretty free follow-ups. We also get this, so it will extend one farther. And yeah. And so now we have this top half. And the top half is a little bit trickier. We can start by looking at this cell, and we can say that, well, if it takes here, which it must do if it does not go to the obvious dot, this collides, this goes off the grid, this is going to go way off the grid. So we get this kind of bow tie shape. Now, I'm going to switch to blue here to show you how I would intuitively do this part. So I would intuitively just give this dot as big of a region as it can, and just kind of go from there. And just see what happens. Give this dot a big region. Alright, we're running into a problem, so we'll steal a cell. And we can see this kind of give and take in a Spiral Galaxies. And this arrives at a solution pretty quickly. Now obviously I do know what the solution is, but that's pretty close to how I solved it when I was just going for a solution in a test solve. Do the start rigorously to get somewhere, and then do up here afterwards. Now, if we look at this cell, this is kind of the crucial cell to look at. It must go to this dot. We don't know if it's going to go through this middle cell, but we can pretty quickly see that it must do so. Why does it have to do so? Because what happens if it doesn't? Well, we're going to have to do this kind of thing. And then, well, then what's going to happen? How are we ever going to fill here? We're just never going to be able to. So, in that regard, we get this straight line. You could intuitively connect that, but you don't really need to. This cell now causes a problem. And again, we just expand what each dot must take. Now this cell, kind of forced here, expands the region. Let's add the extra edges in. Actually gives us the entire region. We now get this block. Note that this cell cannot join this block. So we get those trapezoids. And yeah, this Spiral Galaxies is much simpler than the other one. But, you know, it can still take a little bit to get going and kind of acclimate to what's different. But yeah, here is the solution to the hexagonal Spiral Galaxies. I hope that was informative. I hope that kind of showed how you can solve these puzzles. And we'll be back, or I should say I'll be back, with more solutions for the next set of 3 fairly soon. Until next time, later.